Hello, everybody. Today we will be talking about tessellation, which is about polygon. All right, tessellation. We are talking about polygon. There are two types of polygon which we can see tessellation. One is regular, the other one semi-regular. All right, and we will go through what regular and semi-regular polygons are. First thing, the reason why tessellation is important because tessellation is an important technique or topic in crystallography. And the reason why it is important because um, in crystallography, um, tessellation is being used to identify crystal, and those crystal is important for microchip. So when we talk about regular polygon, that means that the polygon at any vertex or internal or interior angles are congruent. Okay, and um, for semi-regular, at any vertex, you will see more than one angles. So I just included one semi-regular tessellation here. Let's talk about this one. Okay. And this is 1, 2, 3, 4, 5, 6, 7, 8. 8. So it's octagon. All right. So the interior angle for this one, basically, there are two important formulas. To calculate interior angle, we can use this formula. So octagon has 8 sides, and interior angle of a polygon can be calculated equal n minus 2 divided by n times 180. So when we have this, we can see here this is 8 minus 2 divided by 8 times 180. Okay, if we are using a calculator, so 6 divided by 8 times 180, so it's 135. Okay, so this is 135. And we have this square, and we know that square interior angle of a square is 90. So you can see um, this semi regular tessellation, they are two interior angles at one vertex, at this vertex, at this vertex, two types of interior angles, 135 and 90. Okay, let's talk. We can also look at regular. So this three are all regular. You can see here this is 90, and this is triangle, and we know that triangle When they are regular, that means that is equilateral. Each of them would be 60. And this is hexagon. Hexagon. It means 6 sides. So using that formula, right, interior angle equal n minus 2 divided by n times 180. So it'll be 6 minus 2 divided by 6 times 180. That is 4 divided by 6 times 180. So using a calculator, 2 divided by 3 times 180, that is 120. That's 120. 120. Okay? So you can see they are all 120. I will change the color just so that it will be easier. 20. They're all 120. Okay? We can also try to see if 60gon, the polygon that has 16 sides, whether it's tessellable. So using the same formula, right, interior angle equal 16 minus 2 divided by 16 times 180. Now we call up the calculator. So 14 divided by 16 times 180, that is 157.5. The next thing what we need to do is we need to determine if 360 divided by 175, 360 divided by 157.5 is 2.286. This is not an integer. That means that if this is not an integer, this is not testable. Okay? All right. So the next thing for an extension question for this semi-regular tessellation, you can see here, this particular vertex, you can see 135 and 190. So let's see in terms of calculation if this is in line. So we know that one is 135, the other one is 90. So um, say let x be the number of 90 degrees and y be the number of 135 degrees in order to make the vertex 360 degrees. Okay, so it'll be 30. I'm running out of space. So the formula, let's use this space. So it will be, oh, I can adjust it. 90 x plus 135y equal 360. Let x be 1. So 90 times 1 plus 135y 360 equal 360. So let's work out what this is. So 360 minus 90 y is so 360 minus 90 divided by 135. No, 270 divided by 135. That is 2. Okay, so it means that 190 degrees is pairing with 2 of 135 in order to form a tessellation. Okay, all right, that's the end. Bye for now. That's the end. Bye for now.